All right. The first thing let's talk about is implicit. Up until now, we've always done things explicitly. We have taken the derivative of y explicitly with respect to x. Whereas all of our functions, we could say were in this, like this. We had x and y separated. So y is a function of x. That's explicit differentiation. Implicit functions do not separate the variables. We'll get the same answers. It's just that now we don't have to worry about separating the equations. Here's the only rule that we have to remember. Whenever you take the derivative of y, you must place a dy dx behind it. Because y is still a function of x, but they're all going to be all combined from here on out. Is that implicit or explicit equation here?
Implicit,
Yes, why?
because it's not separated.
Right, because x and y are mixed up together. So it's an implicit function. Let's go ahead and take the derivative of this. Find dy dx. So let's look at this. I need a whole bunch of room. So we have x cubed plus y cubed minus 9xy equals 0. We're looking for dy dx. Again, it's going to be the algebra part that's going to be the most tricky part here. The calculus part is just straightforward. So let's take a derivative of each part. So what's the derivative of x cubed?
3x 3 x 2 3 x 2 3 x 2 3 x 2 3 x 2 3 x 2 3 x 2 3 x 2 3 x 2 3 x 2 3 x 2 3 x 2 3 x 2 3 x 2 3 x 2 3 x 2 3 x 2 3 x 2 3 x 2 3 x 2 3 x 2 3 x 2 3 x 2 3 x 2 3 x 2 3 x 2 3 x 2 3 x 2 3 x 2 3 x 2 3 x 2 3 x 2 3 x 2 3 x 2 3 x 2 3 x 2 3 x 2 3 x 2 3 x 2 3 x 2 3 x 2 3 x 2 3 x 2 3 x 2 3 x 2 3 x 2 3 x 2 3 x 2 3 x 2 3 x 2 3 x 2 3 x 2 3 x 2 3 x 2 3 x 2 3 x 2 3 x 2 3 x 2 3 x 2 3 x 2 3 x 2 3 x 2 3 x
The next one, what's the derivative of y cubed?
3y squared.
And remember, y is a function of x. What do you have to, what's the rule say about taking a derivative of y? Whenever you take a derivative of y, what do you have to do? I just put it up there. Look at your notes.
dy dx.
You have to put a dy dx behind it.
Okay.
Because remember, since y is a function of x, this is implicitly a chain rule. The outside function is 3y squared times the derivative of the y, which is dy dx. Minus 9. Now we have a product rule here. So the derivative of x is what?
1.
The derivative of y is what?
dy dx.
Very good. Dy dx. So since it's the product rule, we add. So we have y plus x dy dx equals 0. The derivative of 0 is still 0. Now we got to solve for dy dx. We just took the derivative. Now we got to solve for dy dx. Let's first get rid of all the parentheses and brackets as we can. Distribute that. So we have negative 9y, negative 9x, dy dx equals 0. All right. What's our next step? What are we solving for? We're solving for dy dx. So that means dy dx has to be on one side of the equation. Everything else that doesn't have dy dx goes to the other side. So what do we move first? Are there any of those terms that don't have a dy dx on them? 3x squared, that doesn't have a dy dx. So we move that over. The 9y, that doesn't have a dy dx after it. So we get rid of that. Okay. We have all the dy dx's on one side, non-dy dx's on the other side. Remember, we're still trying to solve for dy dx. We want dy dx by itself on one side. How do we do that?
You factor it out from the left side?
Right, algebra, just factor it out. They both have dy dx. I want dy dx by itself. I have to get rid of this. How do I get rid of that? How are
Divide.
they connected? Divide. Just divide both sides by 3y squared minus 9x. Are we done?
No.
Why not?
We have to plug it in into the function.
Nope.
No?
Because all the question asks us to do is solve for dy dx. Can we do anything on this side?
No.
Do they have anything in common? Yes, you can. There's a 3 on top. What we got? So we have negative x squared plus 3y. There's a 3 on the bottom, which is y squared minus 3x. The 3's cancel. So my final answer is negative x squared plus 3y over y squared minus 3x. That's my derivative. You cannot forget to always simplify your equations. Right? This question could have been stated differently. It says, I could have said, find y prime. They mean the same thing. Again, you just have to remember that y prime means dy dx. So how do we get dy dx? Which means we're looking for the slope. How do we find the slope? Anybody? How do you find the slope?
First derivative.
First derivative. Very good. So what's the derivative of this equation? What's the derivative of y squared?
2y dy dx.
2y dy dx. What's the derivative of x?
1.
So what's my next step?
Um, mm,
Isolate the dy over dx.
Very good. Isolate the dy over dx. I want to keep that by itself. How do I get it by itself?
Divide on both sides. Divide 2y on both sides.
Right. I know what you meant. So dy dx is 1/2y. But we can go one step further here since we only have one variable left. What is y equal to? What is y? All we know so far is y squared equals x.
1/x?
How do we get y by itself?
Square root. So
Square root.
y equals square root of x.
Almost. You're halfway there. The plus or minus. Everybody know why we put a plus or minus in front of it? Let's go review algebra again. If x squared equals 4, right, if I square root it, those cancel. Because now since it's squared, x can equal +2 or x can equal -2. Whenever, ever, you take whenever you have x to an even exponent, whenever the exponent, the degree is even, and you take the even root of that equation, it's always going to equal plus or minus that even root. Because if it's even, it can be positive, negative, negative. Only time signs are strictly enforced is if it's an odd degree. So our dy dx is 1/2 radical x, plus or minus. So what does that tell us? This is a plus or minus 1/2 radical x. Why is this a true solution? To know that, we have to look at the original equation. When we solve for it, we got y equals plus or minus radical x. What does the square root of x, the graph of it, look like? Well, can x be negative? Square root of negative x? No. Can x be 0?
Yes.
Square root of 0 is 0. Can x, when x is 1, what's y? Square root of 1 is
1.
1. When x is 4, what's y? 2. When x is 9, 3. So the graph grows slowly like this. That's on the positive side. Now for the negative side, I just do the opposite. Is it a function? No. We knew it wasn't a function because y squared equals x. That means you can it's you get two y values for the same x value, which is not a function. Vertical line test. So what this tells us that if we take points on the top part, those are all positive slopes. If we take points on the bottom part, it's always decreasing. So all your slopes here are negative. That's what this tells us. Yeah, implicit differentiation is probably one of my favorite parts of calculus because it has so many uses. You're not restricted now what kind of functions you can use. And in reality, whenever you deal with nature or space, you have implicit functions. All right. Find the slope of x squared plus y squared equals 25. At the point 3, -4. Come on, focus. There. Is this an explicit function or implicit? It's implicit because x and y are on the same side. And we can't really separate them because if we did, if we move the x over, we take a square root of y, then we have a plus or minus. Now we don't have a function anymore. We know that the equation of a circle, this is it. The center is at HK. Since there's no H and K here, it's centered at the origin. And it has a radius of r squared equals 25. That means r equals 5. What we're looking for is at 3, -4. What's the slope of the curve at that point? Half of the battle is won already because we know it's what? It's going to be positive or negative.
Negative.
Because it's going up, it's positive. So we know that our slope has to be positive. So how do we find the slope? What do we need to find? To find the slope, we need to find y prime. So what is y prime? What's another way of writing y prime?
dy dx.
Very good. So we have to find dy dx. So we take a derivative of this function. What's the derivative of x squared?
2x.
2x. The derivative of y squared?
2y dy dx.
Very good. Because it's a function of x, it's 2y times the derivative of y, which is dy dx. And the derivative of 25 is? It's a constant, so it's 0. So what's my next step? What's that? Isolate dy dx. How do we do that?
Move over the 2x.
Get rid of the 2x first. So 2y dy dx is equal to negative 2x. Then get rid of the 2y, divide both sides by 2y. So dy dx is equal to, the 2's cancel, so we have negative x over y. That's dy dx. So what's the slope of dy dx? It's at the point 3, negative 4. So our x value is 3, our y value is 4. So dy dx is over negative 3 over negative 4. Negatives cancel. That's my slope. And as we said earlier, remember, it has to be positive. Check, it is. Any questions? What do y'all think about this process so far? It's nothing, it's only one more step. It's the same stuff we've been doing. It's just one extra step. We have to put dy dx after a derivative of y. So it's not really that much more complicated. Y squared is equal to x squared plus sine xy. Find y prime. I'll let you all work on this for a little bit. Too many fluffing of papers. It should be straightforward. We should know how to do it already. What's the derivative of x of y squared? two y dy dx. Derivative of x squared.
2x.
Now we have to use a chain rule and the product rule. Derivative of sine is derivative of sine is
Negative cosine.
Cosine.
just cosine. Remember, think of the unit circle. Sine, cosine, negative sine, negative. We're going this way for derivatives. So that's the outside. Now times the derivative of the inside. So we have x times y. Derivative of x is 1, derivative of y is dy dx. Y plus x dy dx. With 2y dy dx equals 2x plus distribute that y cosine xy plus x cosine xy dy dx. Now move all the dy dx's to one side. So there's one already on this side. We just have to move this one over. Negative x cosine xy dy dx. Negative x cosine xy dy dx. Two y dy dx minus x cosine xy dy dx is equal to 2x plus y cosine xy. Or dy dx's, we want them by themselves. How do we get it by themselves?
Factoring it out.
They're both on that side, so we factor it out. Two x plus y cosine xy. Since I just factor them both out. And then divide both sides by what you're trying to get rid of. Two y minus x cosine xy. And there's your solution. The worst part about it is just a lot of writing. It's not difficult. It's just straightforward. Has there anything new that we haven't done before? It's algebra, separating, factoring, moving things around. Nope. That's everything we've done before. higher order derivatives. So far, we've only been finding the first derivatives. We can find the second, third, fourth, fifth x derivative if we want to. Now, what's important here is since it is each higher derivative is built on those below it, they have to be incorporated in the higher order derivatives. So 2x cubed minus 3y squared equals 8. Find the second derivative. Remember, the second derivative is d squared y over dx squared. So we begin the process. What's the first thing we gotta find?
First derivative.
We gotta find the first derivative. We gotta find dy dx. So the first derivative of 2x cubed is 6x squared. The first derivative of 3y squared is 6y dy dx equals 0. Solve for dy dx. Actually, since this is negative, I'll move that over. I'm going to add 6y dy dx to both sides. So I have 6x squared equals 6y dy dx. And then divide by 6y. So dy dx is equal to x squared over y. That's step one. That's phase one. Now for part B, phase two, I got to find the second derivative. Of this previous one. So obviously, since this is a fraction, I have to use a quotient rule. So the derivative of dy dx is d squared y dx squared. So top is x squared, bottom is y. First derivative is 2x dy dx. So we have 2xy minus, this is a quotient, x squared dy dx all over the bottom squared. So d squared y over dx squared. We don't know, we don't have a dy dx yet, but we did find it earlier. So anywhere we see y dy dx, we put x squared over y in its place. So we have 2xy is equal to x squared over y squared. So d squared y dx squared is equal to 2xy minus x to the fourth over y. Remember, x squared times x squared over y is the same thing as that. So x squared times x squared is x to the fourth over y. Let's go ahead and simplify this further. So what do we do on top? What do we need to do on top? Let's get a common denominator. Right now, on top, we have 2xy minus x to the fourth y over y squared. This one has a y, this one needs a y, so I multiply top and bottom by y. We have 2xy squared minus x to the fourth over y squared. Again, it's all algebra from here on out. You have a common denominator, which is y on top. So we have 2xy squared minus x to the fourth over y squared. It's a fraction over a fraction. So take the top fraction, multiply it by the flip of the bottom. We have 2xy squared minus x to the fourth. X times x squared is x cubed. And that's my denominator. That's my function. Any questions so far? Again, you have to know your algebra. I can't stress that enough. I can only go through the rules that we've been doing, but being able to do the mechanics of it, you have to do it yourself. Well, we have a time we have to meet. Next section is called lenses, tangent lines, and normal lines. I'll send you this, I'll send everything out this afternoon. Now, where does lenses fit in this whole thing? A lens, let's say, for example, for an eyeball, the lens is the out part. And in every lens, there's a point which is called a focus, a focal point. So no matter what, how the light enters the lens, it has to bend to get to that focal point. Now, there's only one point where there doesn't have to be a deviation of sort. So this is these are the lights coming in and over there. This line that's perpendicular to the lens. If it's perpendicular to the lens, so what color I use this? We call that normal. All right, so any line that's perpendicular to the bend or the curve or the surface that it's going through, it's called normal. Another name for it is orthogonal. Or in linear algebra, we call those orthonormal curves. That's the most direct path from the source of the light to the focal point in the eye or of the apparatus, if it's a camera or something. So it works with any type of curves. This is called the folium of Descartes. Rene Descartes. That should be a straight line, or not continuous line. The formula for this is x cubed plus y cubed minus 9yx equals 0. And it crosses, and its focus of these curves is at the origin. So find the tangent and normal lines to the curve at 2, 4. This is, I'm sorry. Understanding what this is looking for. Basically, what are we looking for here in this equation?
The line,
Which lines?
and
And,
normal line.
right. Remember, now how are tangent and normal lines related? How are tangent and normal lines related? Let's go back up here. How are tangent and normal lines related? So if this is our point there, the tangent line to this curve, yes. This is my tangent line to that lens. So the normal line is perpendicular to it. So these are perpendicular. This goes back to algebra. So tangent lines and perpendicular lines to tangent lines, how do we tell them apart? What distinguishes them? Because they're both going to the same point. So at 2, at 2, 4, what we want at that point, we want two things to occur. We want to know what the tangent line is to that one. And we also want to know the normal to it. So the question is, how do we find the two equations? Because we're looking for equations of lines. Again, this, I need you to, instead of reading for it, I want you, this to be in your memory from algebra. How do we distinguish between, stop trying to find it in the notes and in the stuff I gave you.
Looking at the diagram.
The diagram's right there. The diagram's right there. How can you tell them apart? What distinguishes them in equations of lines from algebra?
Their slopes are inverse of each other.
Or what?
Their slopes
Or what?
are like they're opposites of each. I don't know how to explain it, but like I guess inverse of each other's. One's either negative or positive, or if it's a fraction, it would be like an integer to over a fraction.
Very good. You found it in the notes.
No, I didn't.
Right. They're negative reciprocals of each other. That's what I'm looking for from algebra. They're negative reciprocals of each other. What does that mean? If the slope tangent was 3/5, then the slope perpendicular to it, or I would go like this, opposite signs and the reciprocals. Those are the differences between the slope of the line tangent and the slope perpendicular to that. You flip the values and you change the signs. So since we know that now, all we have to do is find the slope of the line tangent to it. How do we find the slope of the line tangent to a curve? It's not on your notes. How do we find the slope of the line tangent?
First derivative.
First derivative. So we find the first derivative to our function at the point 2, 4. So our equation the first derivative. So we have to first find dy dx. So we have 3x squared plus 3y squared dy dx minus 9. This is going to be a product rule. X, y, so it's 1 dy dx. So it's y plus x dy dx. Hopefully by this time you already know how to take derivatives. That's why I'm not too worried about. If you want me to slow down, I could do that. But by this time, we should be able to figure out slopes of lines from algebra and basic calculus. Now we gotta distribute that 9, this equals 0. So we have 3x squared plus 3y squared dy dx, negative 9y, negative 9x, dy dx equals 0. We have to get dy dx isolated. So whatever's not dy dx goes to the other side. So we subtract 3x squared. And we add 9y to both sides. Three y squared dy dx minus 9x dy dx equals negative 3 squared plus 9y. If this is too much for you, we can go ahead at this point, I mean, even at the beginning, we could plug in 2, 4 into our equation and solve for dy dx. If you want to, if you don't want to look for an equation of the line. So let's go ahead and plug those in there. So we have, this is my x, this is my y. So we have 3, 4 squared dy dx minus 9 times 2 dy dx equals negative 3, 2 squared plus 9 times 4. 4 squared is 16, 3 times 16 is 48. Dy dx, 9 times 2 is 18. Dy dx. 2 squared is 4 times negative 3 is negative 12. 9 times 4 is 36. (48) minus 18 is 30. Dy dx. 36 minus 12 is 24. Divide by 30. Dy dx. 24 over 30. They both have what in common?
12.
They both have a 6 in common.
I
So
mean,
6 goes
yeah.
into 24 4 times and a 30 5 times. So what does this number find for us? Not that number. What does this number find for us?
The tangent for 2, 4.
Almost. Doesn't find me the tangent.
The slope of tangent line at
This is the
2, 4?
slope of the line tangent. To the function at 2, 4. It doesn't find us anything else, just finds me the slope of the line tangent to the curve at 2, 4. So what do we have to find now? What's the slope of the line normal to it? Very good. So the slope of the line normal to it is -5/4 at the point 2,4. Are we done? No. We haven't found the equations of the lines yet. Was the whole function, the set is find the line's tangent and normal to the curve at 2,4. So here's we know the slope of the line tangent is 4/5. It's at the point 2,4. So how do we find the equation of the line tangent? Since it's an equation of a line, we know it has to look like this. What's the only variable we don't know the value of?
B.
B. We have M, we have X, and we have Y. So all we have to do is find B. So 4 is equal to 4/5 times 2 plus B. 4 equals 8/5 plus B. 4 times 2 is 8. You can do it however you want to find B, but I like to get rid of the fractions first. So I multiply each of my terms by my LCD, which is 5 in this case. I don't have fractions anymore, so I have 20 equals 8 plus 5B. Makes it much easier to find the values. Subtract 8. So I have 12 equals 5B divided by 5. So my B value is 12/5. The slope was 4/5, and the y-intercept is 12/5. So this is my equation of the line tangent. So that's the equation of the line tangent to the curve at 2,4. Now we got to find the equation of the line normal to the curve at 2,4. Well, we know the slope of the normal line, of the perpendicular line, is -5/4. We just redo what we just did. This I'm using the new slope. The y value is 4. -5/4 is my slope. My x value is 2. The 2 and the 4 cancel. So I have 4 equals -5/2 plus b. multiply each of my terms by the LCD. Two's cancel, so we have 8 equals -5 plus 2b. Eight plus 5 is 13 equals 2b. So b is equal to 13 over 2. Plug in my slope and my my perpendicular line, and there's my equation. The last 20 minutes were nothing but algebra. Nothing calculus was involved. It was all algebra. The only thing we did in calculus right here, was find the dy dx from this equation. And that was mostly algebra also. That's just solving for dy dx. What was calculus in there? The only thing calculus-y was from here to here. That's all calculus. The first derivative. From there, it was algebra, solve for dy dx. You won't have time for the next part. That section. We have 2 more sections left to go in this chapter. We'll find derivatives of inverse functions and what the last one was. That is something else. But again, you have to remember, review the stuff that you did in algebra and trigonometry to make this stuff much easier for you. What is an inverse function? From algebra. What is an inverse function? How do you find an inverse function?
By replacing x and y.
Switching x and y and solving for y. Right. Correct. So you have until Wednesday to review this stuff. Review the basic concepts of inverse functions. Yeah, because that's right. Section 8 deals with the algebra part, all the way up to logarithms, because inverse functions are the opposites. Like square root is the inverse of x squared. Cube root is the inverse of x cubed. Logarithms are the inverse of exponential functions. We know what they're supposed to be, we just have to be able to find them. And now we got to be able to find derivatives of those. And section 9 of this chapter deals with trigonometric functions. Inverse functions are also called arc. So the inverse of sine is also called the arc sine. The inverse of cosine is arc cosine. And so they have different names. Please, please, please start reviewing, brush over your old notes, because we spend more time reviewing algebra and trig than we're doing calculus.
Is there like a section on the textbook that you would like us to cover this for people?
I want you to know, just look at your old notes from algebra trig, or even go to YouTube and look at a video, or just refresh your idea what these things are. Because the more you can do beforehand, the much faster we can go in class. Because I would much rather go at a decent pace through chapter 3 than chapter 5. Because chapter 5, we have to get done. So if we only have 2 days to cover 4 sections, guess what? I'm going quick. So I would much rather go over stuff that we did already in algebra and trig, and save it for stuff we've never seen before. So I can't stress that enough, is please, please, please start reviewing your algebra and trig notes.